invite our very first speaker. Yeah, so Thisarasinghe. Yeah, the first speaker is BS Thisarasinghe. So he's going to talk on energy efficiency resource scheduling for computing. So he's an undergraduate at the Thisarasinghe University of Sri Lanka. Just finished his studies thereafter following BSc special degree in computing and information systems. He studied programming and worked with different programming languages in different projects in Sri Lanka and foreign countries as well. He has followed study on fog environments on the purpose of managing energy in fog environments. So we'll invite the first speaker, Thisarasinghe, to start his presentation.
Good morning everyone. Today I am going to present my research on the topic of energy efficient resource scheduling and for computing. My name is Thisarasinghe. My supervisor's name was Dr. KPN Jayasena. First of all, as you can see, this is the content of my research presentation. I will describe each one by one in the presentation coming slides. First of all, I will describe the background of my research. As we all know, cloud computing is a trending technology in the current world now. But this, when it comes to cloud computing, it has a problem which it doesn't support real-time data answering. That's because when an application is connected to the cloud, the application is here, cloud is here. When the user sends a request to the cloud, it goes to the cloud, then the request is processed in the cloud, then the response is coming back to the user. It takes some time. Therefore, this matter takes some time. So therefore, it doesn't support real-time data answering. That's why Cisco presented this new technology called fog computing. This fog computing technology is an extended version of cloud computing, which has implemented fog devices at the edge of the network near to IoT devices. So it supports real-time data transferring because when it comes to processing data, fog devices take care of it. Since it supports real-time data transferring, it transfers data always, processes data always. So it consumes lots of energy. That's why I can come to a decision that I want to do a research to manage the energy in cloud and fog computing environment. Therefore, I had some objectives to do this research. As you can see, I wanted to implement my own task scheduling method in fog computing, and I wanted to propose another meta-heuristic algorithm to solve NP-hard problem. And in addition to implement that algorithm, I wanted to simulate my own smart healthcare application in iBoxing. After that, I wanted to, after I implemented my optimization algorithm, my meta-heuristic algorithm, I compared it with other meta-heuristic algorithms and heuristic algorithms. So, moving to my next point, I will describe the problem statement and research questions on my research. While I was doing this research, I had some problems. As you can see, on the top of the presentation slide, as you can see, my problem statement is there. My problem statement was how to manage energy efficiently in fog environment. That problem statement was retrieved from my research questions, as you can see. And my objectives are in the other side of this diagram, and these objectives are for solving these research questions. These each objectives and main objectives solve my problem and statement and research questions. So now I am going to describe the methodology of my research. First of all, I will describe what are heuristic algorithms. Heuristic algorithms are mainly focusing on the efficiency of the research. Therefore, sometimes it skips some steps in the process of finding a solution. Therefore, it doesn't find the optimal solution for the problem. But after that, meta-heuristic algorithms came. Meta-heuristic algorithms mainly focus on the optimal solution, best solution. Therefore, it doesn't skip any step. It finds the best solution among substitute solution. After that, and in a reasonable time. So, to manage this energy in a fog environment, task scheduling should be done. This task scheduling is known as the allocating tasks for better utilization for particular resources. So what I did was created my task scheduling algorithm. It is a well optimization algorithm and implemented the iFoxing simulation tool because I didn't develop this with real-world IoT devices. So this well optimization algorithm is a meta-heuristic algorithm, in other words, farm intelligent algorithm, and its process is like humpback whale finding a prey to hunting. That means it covers the solution like a humpback whale covers the prey and attacks it by surrounding it. That's how well optimization process happen. It's called bubble net attacking. So as you can see in this image, in the fog environment, first of all, user sends a request. After some process, fog node sends a response. What I did was I implemented my well optimization algorithm in the middle of this process. So, well optimization algorithm was implemented to minimize energy and cost consumption in this research. So, so here we come to the implementation part. First, what I did was I created a fog device by creating fog device class in iFoxing simulation tool. So after that, I created sensors for creating user requests. After that, I added mobility part for those IoT devices. After that, I defined application objects. Then I created application model for object with different requirements. That means application model is a management component in iFoxing. Then I dealt with other requirements as well. After that, I created my well optimization algorithm and added it to fog broker in iFoxing and extended data center broker, and I added it to the main class of the application. When it comes to these applications, when I want to implement my algorithm, I want an application. There are two applications already implemented in iFoxing. So I created another my own smart healthcare application. I will describe them now. First of all, there's a VR game fog application. This is a gaming application. We can it's like we have a device to connect it to head, and using brainwaves we can control the computer interaction. And DCNS fog application is a monitoring application, and smart healthcare application is, as you can identify with the name, it's a healthcare application with pulse oximeters and ECG monitors and so on. And when it comes to analysis, I further analyze by changing parameters of this application. I change number of cameras and number of areas, several parameters, as you can see in the slides, in several applications. As you can see, these are the diagrams for DCNS fog application. The black color represents the well optimization algorithm. As you can see, it has the less energy and cost consumption. And this is for VR game application. This is for smart healthcare application. After comparing those algorithms, I compare PSO and well optimization meta-heuristic algorithms again. And as you can see, in DCNS fog application and VR game application, and after that finally smart healthcare application as a well optimization algorithm for the less energy and cost consumption. According to those results, I came to a conclusion that meta-heuristic algorithms are better than heuristic algorithms, and comparing meta-heuristic algorithms, well optimization algorithm is better than heuristic algorithms, PSO algorithm. So now, as a novelty of my research, there has never been an implementation of well optimization algorithm in fog environment. That's the novelty of my research. So as you can see, these are the references, few of the references of my research. Thank you so much.
Thank you very much, Thisarasinghe. We can take a couple of questions from the audience. Any questions? Okay, maybe you were referring to some kind of a comparison between how do you validate? I mean, you say this is better than the other one. So, how do you validate your claim? I mean, looking at some real.
Round-robin algorithm and the shortest job first algorithm as well. And I implemented all them in different applications in iFoxim. After that, I ran test cases 10 times and got the array. After that, I compared the final result, energy and cost consumption. According to those results, I came to this conclusion.
Domain dependency, like when you say healthcare.
Yes, sir. Those are the applications.
Right. Any questions? Okay, thank you very much. This is it. Right.